and now we move on how to go green in compressed air. And our speaker will be now Filip Strobach from a company Kaeser Kompressoren, which is one of the world's foremost suppliers of compressed air systems. So thank you are with us, Mr. Strobach, and now floor is yours.
My name is Filip Strobach, and I'm sales manager of Kaeser Kompressoren Czech Republic. Please just let me say a few words about Kaeser company. Kaeser Kompressoren is a traditional family-owned company which is based in Germany with 100 years history that produce premium and efficient and reliable products and design highly efficient compressed air systems. On my first slide, you can see our headquarters and production facilities in Coburg City, which is the North Bavaria, approximately 100 kilometers far from Nuremberg. Generally, it is not easy to go green in the compressed air very fast, but using the basic principles mentioned in my presentation helps to save money and reduce CO2 emissions to everybody. The technology is more than hundreds of years known. And speaking about screw compressor, the technology was patented at around 1880. So then in 20th century, from around 30s in 20th century, it was slowly developed. Unfortunately, there are no hybrid compressors on the market like in the car industry, but we are using high efficient electric motors. This is the standard for stationary compressors. This is also forced by governments to use the electric motors with minimum IE3 class for all stationary compressors on the market. Now there are also the portable compressors that they are using for example, for construction on the streets that are able to work with electrical engine instead of diesel-driven engine, as was in the past. And the usage is mainly used, or the use of that compressors is mainly in the cities where there are good power infrastructure, and you can switch from the diesel to electrical power and reduce CO2 emissions in the city. So basically there is no revolution in our market, but there is a continuous evolution. So therefore, to go green in compressed air means that we have to work smart. So let's start. How to determine the compressed air needs. Let's take an existing production as a sample because it's a little bit easier. First of all, it's important to specify the airflow and minimum working pressure and air quality. And knowing these inputs helps you to choose the right compressor technology and design the compressor room setup. This is the common job for you as a customer, and this is the job for compressed air experts. Air pressure and air quality usually defines the production technology suppliers. But how to determine the airflow needed for your plant? I suggest to perform the compressed air audit. Sure, you can try to calculate all production scenarios by hands. And however, the human brain is very useful and powerful tool. It cannot compare all. The right audit of the compressed air will give you the deep insight into your air production that specify or shows you the minimum, average, and maximum air flow needed. It also shows you the fluctuation of the air during the shifts. then the good audit also describe the pressure drop between the compressor room and the point of use, and also shows the air leakages of the system. After the measurement, the log data has to be evaluated and can be used for simulation, for a new compressor room scenario, or for exchange of the single compressor or more compressors in your system. And there is no right solution, no one right solution. There are many solutions. You can really work out tens or hundreds of the solutions, and it's good game to compare what is better or what is more efficient concerning the energy, and for example, what is good for the safety of the production and so on. So the calculation program that many producers are using can compare many solutions, and can you decide whether to use the most effective system or the system with fast payback. For comparison of the efficiency of the system, use specific power according to ISO 1217 standard. We can simplify it that this value is the efficiency of compressor or efficiency of the compressed air system. And it allows you to compare the different size compressors from different producers and different models. The formula is mentioned in the slide below the text, and it's quite easy. You have to divide the total power consumption of compressor or system by the effective flow rate of compressor or system in the same pressure. Finally, the figure you will get that specify the efficiency. Normal pressures at around 6-7 bars. The efficiency is somewhere around 5, or is somewhere from 5.5 to, I don't know, tens or whatever. The important is that the lower the specific power is, the more efficient the compressor or system is. Let me say also a few words about variable speed compressors. In Kaeser, we call it sigma frequency controlled compressors. There is a strong marketing that variable speed driven compressors solve all your needs and save minimum 20, 30 or up to 50% of your energy cost. It is a very nice marketing argument, but variable speed compressors must be designed and used very carefully, because variable speed compressors is not always a solution for decreasing of your energy bill. We have seen many systems where using variable speed compressors brought customer higher investment cost, higher service cost, and also higher electricity cost comparing proper size base load or load unload compressor. And for larger system, for larger air system, you need definitely master controller. Implementing the clever master controller to manage your compressed air system brings you more benefit than just energy saving. It also optimizes the service intervals, allows you to monitor and control system remotely. It can store the data, including the alarms and failures, and gives you the opportunity to export the data for your energy management system according of ISO 50001 to the files. You can work with them later on. So, like for example, Excel files and the others. Another valuable feature of the screw compressor or rotary compressors generally is the heat recovery. It is a free energy that you can gather from your compressed air system. You can recover, based on the type of the compressor, up to 96% of electric power for air or water heating, sanitary water heating or preheating, or process water preheating. Nowadays, when power and gas are extremely expensive, the heat recovery having very fast payback. We receive significantly more of inquiries for compressors equipped with the heat recovery systems, and also many companies that in the past refused our offer for heat recovery system now coming back with the request for a retrofitting of existing compressors and existing system by these exchangers. We look or move from compressor to the pipeline system, we can also find a lot of possible savings. Reducing the required system pressure and pressure drop of the air treatment equipment always reduce the power consumption. The rule of thumb says that approximately 1 bar lower the pressure, operating pressure of the system is, means approximately 6% of the energy saving. I also recommend to use the high quality and rust-free pipeline, and maintaining the connection hoses, quick couplers, and the other components of your system properly to reduce the air leaks and save your energy and service bill. The air leaks never sleeps, you know, so when the air leakage is caused by technology itself, we strongly recommend to install the shut-off valves upstream the production lines and close the valves when production stops. It can be done manually or automatically. There are many options on the market. Also, using the efficient compressed air dryers, the filters, and another equipment or components would save a lot of kilowatt hours and service cost too. I recommend to choose the dryers with low dependent control system that reduce the energy consumption when the system works in partial load. Also, the beneficiary is used heat generated absorption dryers instead of heatless absorption dryers for higher flow of the compressed air, basically over the 1,000 cubic meters per hour. But you can also find the equipment that with smaller capacity. So if you would like to really go more efficiently, you can also find the heat regenerated dryers for a lower capacity than 1,000 cubic meters per hour. But sure, the equipment is more expensive. On the other hand, saving the energy. And some of the refrigeration dryers called refrigeration dryers for drying the air for approximately to the class 4, which means +3 degrees Celsius, use the refrigeration gases for their operation. We produce and deliver, and I recommend to use only the dryers with newest refrigeration gases that has low impact to global warming potential. So to sum up and simplify the above slides, I strongly suggest to make the research, because comparing the specific power allows you to choose the efficient compressor. Then to measure, because measurement allows you to design efficient system and find potentials of the savings. If you have more than 2 compressors, it's good to use the master controller, because master controller increasing the efficiency of the compressor system and not only. Heat recovery. Heat recovery, as was mentioned, brings you a huge amount of the free energy. care about the pipeline, because pipeline or by reducing the required system pressure and pressure drop and air leaks, we are saving unnecessary usage of the air and the power. And finally, with the right treatment, you will save energy and environment. So, to the real end, all above basic steps for compressed air system design brings you the complete potential of energy and money saving, heat and gas saving, and CO2 reduction. And this is our contribution to the green policy. As I was mentioned in the beginning of my presentation, go green means go smart. Thank you very much.
Thank you very much. Thank you very much, Mr. Strobach, for your insights. I have one question as well, because nowadays many people really are thinking about how to fix their energies because of growing prices of gas and electricity. Would you recommend what, in your eyes, what's the best way how to get energies right now for, let's say, a small family house with 4 people? Is it a heat pump or gas boiler, or what would you recommend to an ordinary Czech family? How, in the regard what will come in the next years and what the prices of energies will be, what should be the main sources of energies for heating especially? Thank you.
So it is a little bit out of our main let's say business, but from my previous experience in the market or with, for example, cooling systems and the heat pumps, I trust the use the heat pumps in using of the heat pumps. Sure, it is quite costly solutions, but on the other hand, the government used or support the using or exchanging of the fossil boilers, exchange of the fossil boilers for heat pumps, for example. So this is one way, and this is the way that is quite let's say nice for me, because it is how gas are running out of the gas, first of all. Second, you can let's say save the energy, because depends on the machine you consume 1 kV and you would get 3 or more kVs for heating. And sure, for example, in summer times, at some systems you can use free cooling if you, for example, use the drills for the primer source of for the heat pump. So my favorite is using the heat pump. Even I know that this is not for everybody, because the investment cost is quite high.
Great recommendation. Thank you for it, and thank you for your presentation as well, of course.